So this is a quick video going over a broad overview of naming ionic or covalent binary compounds. So when I say binary compound, what I mean is a compound that's made up of two things. So either two elements or possibly one or two polyatomic ions. So the first thing that you need to do when you are naming a compound is determine whether or not it's ionic or covalent. Because if it's an ionic compound, we're going to use the rules for naming ionic compounds. If it's a covalent compound, we're going to use different rules to name it. So we need to be able to distinguish whether it's ionic or covalent, and that's what this video is going to focus on. So how can we tell if something is ionic or covalent? Well, what we need to do is determine whether the elements that make it up are metals or nonmetals. So covalent compounds are made up only of nonmetals. So for a binary compound, you're going to have a nonmetal plus a nonmetal element. So if both elements making up the compound are nonmetals, you're going to have a covalent compound. For ionic compounds, you can have a metal and a nonmetal, and keep in mind ionic compounds are made up of ions. So in this scenario, these are going to be two ions. And the other thing you can have is you can have polyatomic ions, which are ions, so they form ionic compounds. So this raises the question of how we know whether the elements are metals or nonmetals. And that's where you're going to want to look at a periodic table. So on the periodic table, on the left side of the periodic table, you're going to have the metals. So everything in group 1A and 2A are metals. The transition metals in this middle block are metals. And then there's some metals over here. So everything that's to the left of the semimetals, or the metalloids, which are shown in blue on this, are going to be metals. The nonmetals are going to be over on the side of the periodic table. And I'm not going to include any examples with semimetals, which are also called metalloids, just for the sake of simplicity. So you can use the periodic table to determine whether or not you've got a metal or a nonmetal, and that'll allow you to determine whether you have an ionic or a covalent compound. So let's just go through a couple examples of that. So for our first example, let's take the compound MgCl2. So I have a magnesium and two chlorine atoms in this compound, and I need to determine whether or not they're metals or nonmetals. So magnesium is located on the left side of the periodic table. It's in group 2A, so that makes it a metal. Chlorine is way over on the right side of the periodic table, so that's a nonmetal. Which means that I have these criteria here where I have a metal and a nonmetal. So this is going to be an ionic compound. And I would proceed to name it using the ionic naming rules. Now let's look at a different compound. Let's look at the compound PCl5. So we have one phosphorus and 5 chlorine atoms in this compound. Both phosphorus and chlorine are on the right side of the periodic table. They're both nonmetals. So that means that this compound is made up of two nonmetal elements, and that means that it is a covalent compound. Let's do one more example. So the last example I'm going to do is going to look like this. So NH4NO3. So you might be looking at this and thinking there's more than two elements in this compound, and you are correct. However, what we're looking at here is a compound that's made up of two polyatomic ions. So if you have a table of polyatomic ions, if you do see a binary compound that has more than two elements, you know you need to be looking for some polyatomic ions so you can compare it to your table and identify those ions. So I have here this ion NH4, which is the ammonium ion. So by itself, that looks like NH4 with a +1 charge. And then I have here NO3 with a -1 charge, and that's the nitrate polyatomic ion. So since this compound is made up of ions, it's going to be an ionic compound. So that's just a few examples of distinguishing between an ionic and a covalent compound. The last thing I want to talk about is just to briefly mention what this naming system that I'm going to be going over does not include. So when we're talking about the naming rules that I'm going to go over for covalent compounds, we're really talking about inorganic compounds. And what that means is acids and organic compounds are not included in the naming scheme that we'll be focusing on. So an acid, if you see something that starts with a hydrogen, that's a pretty good clue that it's an acid. So if you see something like HCl or HNO3, this is hydrochloric and this is nitric acid, and those have their own naming system. Organic compounds, if you need to check and see if you have an organic compound or not, for a binary compound, it's only going to be made up of carbon and hydrogen. So you might have something like CH4 or C2H6. These acids and organic compounds both have their own naming system. And depending on what class you're taking, you may or may not need to know this, so that's definitely something you want to check with your instructor. But I'm not going to be going over those to start with these videos. I'm going to focus on the inorganic covalent compounds. So in the next video, I'm going to go into the details of ionic naming and how that works and go through some examples, and then we'll talk about covalent naming rules.